All right, we are getting our two biggest test questions ready on our review right now. And during off the screen, I went and got this activity, which was the activity from Starboard 2022, 11, 21. I'm basing it on this activity, but I promised I would change it from a double replacement to a single. So this one is closer to yours, the new one. It's going to be a single replacement. Yes, I promise. And you don't have to figure out if the reaction works or not. I'm just going to give you one that works. Like, remember the activity series and we're supposed to predict if the reaction works or not? Well, I've done that for you and this reaction works. So you don't have to look at an activity series. Because we're supposed to be getting ready for the big picture. So some of the little picture items get taken away with the unifying items. We're bringing those together. So we're going to need some formula weights for, you don't need formula weights when you have molarity, because you can go to moles with molarity. That's a shortcut, but I do want you to remember what big M really stands for. I cross it off and replace it with what it really is. What is it? Moles per liter. Okay, so we do need formula weight for zinc metal. And I can't read that far. It's middle of the zinc, cadmium, mercury. Let's to the right in the middle area. What do you got? Just for Zn. Got it. Grams per mole. And we're going to give a balanced single replacement. So we have silver nitrate, that is Ag plus, NO3 minus. Zinc is just zinc. I know you're supposed to memorize ions for zinc, right? But this isn't an ion, it's a metal. All right, so silver nitrate is a 1-to-1. A, silver nitrate plus zinc. You do have to know the zinc nitrate is Zn2 plus and NO3 minus, which is Zn once, NO3 twice. And what's the other product here? I did them out of order. I gave the last product first. What's the other product listed right ahead of that? Silver. What's the formula? Just Ag. You can write solid. You don't have to. Doesn't ask for states. I'm not going to ask for states. There you go. What are we doing next? We got to go grams to moles of silver nitrate, silver metal, sorry, for each reactant. So silver nitrate, we started with 1.1234, sorry. Oh, we didn't balance yet. Thank you. Good students here, keeping me honest. We're not finished yet. Don't move on, Dr. Whitaker. That's good. Yeah, the silver's not an issue yet. The zinc's not an issue yet. The nitrates are an issue, and you got to put a 2 here, which means you got to put a 2 there. So I am picking ones that aren't incredibly difficult to balance, and that will not change, okay? You're welcome. All right, so now you can go to moles. We've got 0.1234 liters. What? That wasn't given. We better show 1 liter for every 1,000 milliliters, right? You can do it right on the question. I have no objection to that at all. I like efficiency. There you go. So that's where that number came from. And then that's times, and I know I needed to do that because molarity is moles per liter. Times 2.345 moles per liter. And somebody's going to give me an answer that's close to 0.2, almost 0.3. I don't know. I'm going to wait. Moles. Oh man, I didn't even have to finish. Oh well. I got moles of AgNO3, correct? I didn't have to write this down. I could have gone using the old coefficients. And I'm making silver. 2 Ags made for how many AgNO3s reacted? 2. Oh, that's good. I had the answer because I need it now, right? 0.289373 grams Ag. Not grams. What are the units? Coefficients are moles per moles. 2 moles Ag for 2 moles. Yeah. Mole. Ag. Okay, next one is zinc. We have 0.5678 zinc. Times 1 mole for every 65.39. And what you got there? That's a 3 down there in case you're having trouble. 0.00868. And that would, I should have done the coefficients, but I didn't. That's moles Zn, right? Times something that gets rid of moles Zn and gives me moles Ag. And moles Ag is 2. Moles Zn is 1. And we're looking at 0.017 something. 36657 moles Ag. Yeah, that's a lot smaller, isn't it? What does that number represent? It tells me what was the limiting reactant. Yeah, the number itself is the theoretical yield. Right? Smaller of the two numbers, these two. You're comparing moles Ag to moles Ag. You're allowed to do that. Moles of apples to moles of apples. And that's the smaller amount. That means this was the one that's running out. And what do we got? I hope I don't have a nightmare is what I'm saying. We have that many grams of silver made. It says convert the grams to moles silver for actual yield. Okay. Let's do that. C. We've got 0.01234 grams Ag. 1 mole, 8. How many grams? I need the periodic table numbers 107. I don't know. So 107.9 if you got my 4 sig fig periodic table. Good. Work that out for me. It's going to be, this is going to be the actual yield. It's going to be tiny. Tell me how tiny. I might change my question to make it nicer. 0.000. I'm definitely changing my original question. Can you just multiply your answer by 10 for me right now? And we're just changing the question to 0.1. So our number isn't a ridiculously low percent yield. It's just slightly ridiculous. And I'm fixing it down here too. She already fixed it on her calculator. And that's 00 now, right? Yeah. 114365. And that will be moles Ag. And don't forget that is actual yield, right? Moles Ag actual. And the two numbers I need, I want them on the screen together. Right there. So actual over theoretical. 0.0011435 over 0.01, the one in the box. Is grams over grams, canceling. It's still ridiculously low, less than 10%. Thing. One more sig fig. What was after the 5? Yeah. When in doubt on this test, 4 sig figs probably going to get you through the whole test. You probably lose at most. If you just did 4 sig figs for every answer on this test, you're going to lose on the whole test, maybe a half point, because I might have a 3 sig fig question thrown in there just to see who's paying attention. But I don't want sig figs to be your preoccupation, is what I'm saying. So I hope we had all of that on video. And there you go. All right.